Inside this Austrian Magna Steyr factory, every Mercedes-Benz G-Wagon is produced. The high quality of this luxury off-road SUV is due to the fact that more than 90% of the assembly is done by hand. Right now, you're watching how the body in white is hand-assembled. Unlike most mass-produced cars, the assembly process of the Mercedes-Benz G-Class is performed by hand by factory workers in Austria. The body in white moves across the factory hall automatically using conveyor belts and lifts. Body in white refers to the stage where the vehicle's sheet metal body structure has been assembled but has not yet been painted or equipped with moving parts or trim. Some welding and alignment operations are still performed manually by technicians to ensure proper fit and accuracy. After assembly, the body undergoes cleaning and degreasing, where it is thoroughly washed to remove oils, dust, and other residues left from the manufacturing process. Right now, you are watching the pre-treatment stage, where the vehicle body undergoes phosphate treatment. In this process, a protective phosphate layer is applied to the surface to improve corrosion resistance and enhance paint adhesion. After this step, the body is processed through electrocoating, in which the entire vehicle body is submerged in an electrically charged anti-corrosion bath. This method allows the coating to spread evenly and reach every cavity and hidden area of the body structure. Once the coating is applied, the body is baked in an oven to cure and harden the protective layer. As you can see right now, the body of the future Mercedes is transported for polishing and inspection after the first layer has been applied. The workers at this station polish the body and check that everything has been done correctly. This is followed by applying fillers to selected joints. Fillers are applied to the joints on the body in white before painting to smooth out seams, gaps, or surface irregularities that result from welding and assembly. Seam sealing is applied to protect the joints between panels from moisture, while underbody protection coatings shield the chassis from stones, water, and salt. The body is then sanded and smoothed to prepare the surface for painting. Sealants, or sealing, are used to fill joints, gaps, and cavities to prevent water, air, or corrosion from penetrating. They are often applied in hidden or structural areas, such as door sills, wheel arches, or panel overlaps. Their main purpose is protection and durability, not surface finish. The painting process gives the vehicle both its appearance and added protection. It typically involves several layers. First, a primer layer is applied to improve paint adhesion and provide additional corrosion resistance. Next, the base coat, which is the main color layer, is applied by automated spray robots. Finally, a clear coat is added, creating a transparent protective layer that enhances gloss and shields the color. After each major layer, the body is baked in high-temperature ovens to ensure durability and a flawless finish. After the final painting of the body, the entire unit is sent for a quality inspection. Experienced workers carefully check the paintwork. The color must be applied evenly and flawlessly before the body can proceed to the next stage of the production line. Here you can see how unique the production of the Mercedes-Benz G-Class is. Much of it, including the painting, is done manually. While robots handle the majority of the painting process, human workers play a vital role in finishing touches and quality control. They inspect the painted surfaces for imperfections, perform minor corrections, and ensure that the final finish meets the high standards required for the vehicle's appearance and durability. For military versions of the Mercedes-Benz G-Class, the painting process differs significantly from standard civilian models. A uniform base coat, usually in a matte military color such as green, sand, or gray, is applied automatically to ensure full coverage. However, the camouflage patterns are not applied by robots because each design is unique. Instead, they are added by hand using techniques such as spraying with paint guns and stencils or airbrushing, resulting in an irregular, varied finish optimized for terrain camouflage. Every military G-Class then undergoes manual inspection, where experienced workers ensure the pattern meets specifications and that critical areas like lights and sensors are not painted over. While the base coat is automated, the camouflage layer is almost entirely hand-applied, making each military G-Class unique. Polishing and paint inspection are exactly the processes that set automakers like Mercedes apart from lower-end car brands. It is this focus on the highest quality that distinguishes premium vehicles from standard models. G-Class car body is cleaned in a process similar to a conventional car wash and is then transported further for processing using sliders and conveyor belts. This is where the paint is mixed and prepared. The Mercedes G-Class offers a very wide range of colors. The finished and painted body is transported to a storage area, where it is kept under optimal humidity and temperature conditions until it is moved to the main assembly line. The entire manufacturing process is very much like a huge puzzle. The production relies heavily on logistics and timing, and the better Mercedes manages these processes, the higher the profits the company can generate. Right now, you can see for yourself how the development of the new Mercedes G-Wagon went in 2019. First, a few test engines and vehicle prototypes were created, followed by months of testing. The 2019 Mercedes G-Class models are part of the new generation. Essentially, 2019 and 2020 G-Class models are from the same generation with minor updates. The entire production process can be divided into several departments, such as car body welding, then the paint shop, or the department where Mercedes interiors are stitched. After the first prototype is completed, the vehicles are taken to a test track, where a full series of tests is always carried out. It is a special off-road course where the suspension response, water resistance, and durability against mud and dirt are tested. This is the Jaguar Land Rover Solihull paint shop in 2018. The paint shop is a cornerstone of vehicle production. Once the body panels are formed and welded, the car body undergoes meticulous steps of surface preparation, cleaning, spraying, and curing. These processes ensure a flawless finish that withstands weather, corrosion, and the test of time. Every vehicle spends many hours in the paint shop, passing through over 20 individual processes, including cleaning, primer, base, and top coat applications, and final inspection before moving on to trim and final assembly. Modern automotive paint processes typically include phosphating, e-coating, and multiple layers of base and clear coats, all baked in curing ovens, a process that usually takes an entire day per body. Paint shops like Solihull's use advanced robotics and precision systems to deliver extremely consistent color, gloss, and corrosion protection across every car. Robots help apply paint in carefully controlled patterns to reduce overspray and waste. This is essential for premium finish quality on luxury models. In 2018, the Solihull plant was preparing for production of next-generation vehicles, including new versions of the Range Rover and Range Rover Sport, which meant it needed flexible manufacturing and paint capabilities to support different body styles and finishes. Right now, you're watching the door sub-assembly before it is delivered and installed in the cars on the main assembly line. The doors are always finally installed at the end of the production line. The reason is to allow factory workers to easily carry out assembly work inside the vehicle. Inside this Land Rover Solihull factory, around 80,000 Range Rover vehicles were produced in 2018. The current process you are viewing is the assembly of a large panoramic roof on Range Rover vehicles. The Solihull plant in the UK remained the main production site for large Range Rover models, where body construction, painting, and final assembly took place. Jaguar Land Rover had invested millions to upgrade these facilities to handle flexible manufacturing and future models. In 2018, more than 9,000 employees worked inside this factory, making it one of the largest automotive manufacturing sites in the UK. The vast majority of them worked and still work on the main assembly line. Higher-end Range Rovers rely extensively on aluminium construction to reduce weight and improve performance, fuel economy, and structural strength. This means the body shop needed specialized techniques, many rivets and adhesives rather than traditional welding, to handle aluminium effectively. With demand for different variants and finishes, manufacturing lines in this era had to be flexible, capable of switching between different models and layout options without slowing production. Robots, automated guided vehicles, and advanced conveyors were all part of this automated environment. One UK survey found that nearly half of Range Rover brand vehicles experience a fault within the first few years of ownership. Surveys and owner feedback frequently rank Land Rover, including Range Rover, below the industry average for reliability, with electrical problems and suspension faults among the most commonly reported issues. Repairs and servicing can be significantly more expensive than for mainstream brands, with some owners caught off guard by high repair bills. Routine maintenance for advanced systems, like air suspension and electronics, can quickly add up. However, certain models, such as the Range Rover Sport, have fared better in reliability surveys than the full-size Range Rover from the same period. Mid-life refreshes, like those around 2018, are often considered the most dependable of their generation, particularly when well maintained. In recent years, annual UK sales have consistently ranged between 75,000 and 82,000 vehicles, highlighting continued strong demand for British-built Range Rover and other Jaguar Land Rover models. Right now, you're viewing the customer acceptance line, where vehicles undergo dyno testing. Right now, you're watching how the Land Rover Defender was manufactured at the Solihull plant. The classic Defender, built at the Solihull plant in the UK, was in its final full production year in 2015. According to production records, about 21,800 Defenders were manufactured that year, before the line closed in early 2016. The Defender was a very popular vehicle globally, especially among off-road enthusiasts, farmers, explorers, and military users. Interest surged in 2015 because it was announced to be the final production year, and demand jumped as buyers wanted one of the last classics. This is how British factory workers assembled the Land Rover Defender chassis. First, the individual parts were stamped, then welded, and finally polished and riveted together. In the UK specifically, new registrations were around 8,674 Defenders in 2015. Every Defender combined approximately 8,900 individual parts in its build process. After a 67-year run of continuous series and Defender production at Solihull, the classic Defender was nearing its end in 2015 due to new emissions and safety regulations that made continued production there unviable. Typically, before the final year, one production shift made around 84 vehicles per day, but during 2015 output was increased to about 125 per shift to meet extra demand. Demand surged partly because buyers sought one of the last classic Defenders ever made, with many destined to become collectibles. Some private collectors even snapped up entire fleets of 2015 Defenders, anticipating their future value. This is body and white polishing. It involves refining the surface of the welded sheet metal before painting. Polishing the Defender's body in white smooths out welds and imperfections, ensures paint sticks flawlessly, helps prevent rust by eliminating moisture traps, and guarantees panels fit perfectly for lasting strength, even under tough off-road conditions. Once the body in white was completed and passed quality inspection, it was painted and then stored in the main warehouse inside the British factory. As you can see, the workers always operate in coordinated teams, each focusing on specific tasks. At every workstation, there is a responsible worker in charge of ensuring the quality of the work performed. While the body was being prepared, a durable and robust chassis was being assembled in another part of the factory complex. Gradually, other components were added, such as brake discs, axles, and eventually the Defender engines. This is the assembly of the 2.5-liter TD I4-cylinder turbo diesel engine. The classic Land Rover Defender, including the 2015 model, was known for its rugged, reliable engines designed for off-road durability rather than speed or refinement. The assembly began with a robust ladder frame chassis, onto which the axles, suspension, steering components, and drivetrain were installed before the body was lowered, a method that ensured extreme durability and off-road capability. The Defender was designed with modular construction. Body panels, chassis, and engine components could be swapped or repaired independently. Unlike modern mass-produced SUVs, many parts of the Defender were assembled by hand, particularly in the chassis, body, and engine installation stages. Each Defender passed through strict quality checkpoints at every stage: chassis, drivetrain, body, and interior, with a responsible worker assigned to each workstation to ensure Land Rover standards were met. Even minor cosmetic imperfections were corrected to maintain the brand's rugged yet precise reputation. Before the finished vehicles were moved into the illuminated LED tunnels where the paint quality was checked, the vehicles were sprayed with water. The Solihull plant emphasized a combination of automation and human craftsmanship. Inspectors ensured that the Defenders met both Land Rover standards and the ruggedness expected from its off-road reputation.